Hi class, this is Dr. Karsten, and today we are going to be reviewing comparing fractions. And this is for Module 5, Grade 4, Engage New York Math. So in today's, not really lesson, but in today's video, I want to review how we compare different types of fractions. And we're going to be focusing on three main ways or types of fractions that we are going to compare. So the first one is if the numerators are the same. So I want to remind you that when the numerators are the same, we can just go ahead and take a look at the denominators. And that's because the denominators let us know about the size of each piece. So remember, and I have a hint here, it says, would you rather share a cake among 3 or 8 people? And that's something I often ask you, is would you rather share something with 1 person or with 10 people? Because the denominator is telling us how many pieces one whole has been partitioned or divided or split up into. So if you had to split a cake into 8 pieces or 3 pieces, when you do it in 8 pieces, those pieces are going to be a whole lot smaller than when you have 3 pieces. And so here the pieces are bigger, which means that if I have 2 of this sized pieces, those are going to be bigger than 2 of the little pieces. So 2 big pieces are larger or greater than 2 of the little pieces. And here we can actually see that. We have 2 tape diagrams, and this one is partitioned into thirds. It's cut into thirds. So we have 1, 2, 3 parts, that's our denominator, and 2 are shaded in. So you can see that these pieces are all really big compared to this tape diagram that has been partitioned into 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. And 2 of those are shaded in. So in both of these, 2 of the pieces or parts or units are shaded in. But here the pieces are much smaller because we had more of them. So remember, when our numerators are exactly the same, we can just look at the denominators. And when we have a smaller denominator, the pieces are bigger. So this one's going to be bigger because 3 is smaller than 8. Okay, next one. So another way that we can look at them is if the denominators are the same. So for example, here you can see that my denominators are exactly the same, which means that the sizes of my pieces or parts are going to be the same. When all of my pieces are the same size, then I can just look at the numerator to see who has more pieces. And here you can see that 6 is a lot more than 2. So since all the pieces are eighths, having more of those eighths is going to be larger than having fewer or less of those eighths. So in this case, 2 eighths is less than 6 eighths. And you can see that here. Both of these have been partitioned off into eighths. Here we have 2 eighths. Here we have 6 eighths. 6 eighths is clearly much, much larger. So that's 2 ways that we can do it. The third type of way, or third type of problem that we might encounter, is if the fractions have different numerators and different denominators. Then you have a whole bunch of different options, and I listed 3 of them here for you. One is that you can compare them on a number line using the benchmarks 0, 1/2, and 1. Another thing we could do is we could draw them in tape diagrams. And a third way is that we could get common denominators by multiplying the fraction by the other fraction's denominator. And we've been doing a lot of that. So in this case, I didn't do all 3 because that was just going to be a whole lot of space, and we've been doing a lot of this, so you should be feeling pretty good about it. But let's go ahead and let's do it really quickly and take a look at it and use this as an example. And then I'm going to do a few more examples after that, but they should be pretty quick. But let's go ahead and do this. Let's compare 1/4 and 3/5. So I'm going to write it down for us on a separate piece of paper, and let's go ahead and make the page. Okay, so I'm actually going to do it all 3 ways for us so that we get a chance to really take a look at this. So the first way that I mentioned was that we can compare them on a number line using the benchmarks of 0, 1/2, and 1. So if I were to put these on a number line, actually I'd like a nice thick number line. So I'm going to start off by putting 0, which is a benchmark, 1, and then right around here is where 1/2 is going to be. And then I can place these fractions on this number line. So if I'm doing a quarter, I know that if I were doing fourths, I would have 0 fourths. I would have 2 fourths, because 2 is half of 4, and I would have 4 fourths, because 4 fourths is equal to 1. So then what I know is that 1 fourth is going to be halfway between 0 and 2 fourths. So this is where 1 fourth would go. And I'll go ahead and write that up here. Now I can do 3/5, and if I want to put 3/5 on here, I don't know if you remember, but I know I keep driving this home to you guys, that fifths are one of those weird ones, and 3/5 is going to fall between 1/2 and 1, closer to the 1/2. And I'm going to show you that in a second, but let me go ahead and put that in. So this is where 3/5 would go. So now I know that 1 fourth is less than 3/5. Now, just really quick to review the 3/5 thing, because you know I have a little obsession with the 3/5 and the 1/3. I'm just going to do a quick sketch and put fifths on here. So we'd have 0 and 1. Okay, and there you can kind of see I would have 1/5, 2/5, 3/5, 4/5. And if I wanted to mark off where my 1/2 would be, 1/2 would come right through here. So I'm just doing a really light line for us to look at that. So now what you can see is that if I'm talking about fifths, 1/5 is between 0 and 1/2, closer to 0. 2/5 is between 0 and 1/2, closer to 1/2. 3/5 is between 1/2 and 1 whole, closer to the 1/2. And 4/5 is between 1/2 and the whole, but closer to the whole. So again, I keep reviewing this. This is something that you really need to get comfortable with and hold on to in your memory. But back to this. So I compared 1 fourth and 3/5, and we put them on the number line, and then we were able to identify which was larger and which was smaller. So that was the first way. The second one was to use a tape diagram. So let's go ahead and let's do a tape diagram for 1 fourth and 3/5. So the most important thing when you start your tape diagram is that you want to make sure that they are really even. You want your tape diagrams to be the same length. And I've actually known people who attached them to make sure. Okay, if they're not the same width, that's not quite as big a deal. So for 1 fourth, I need to partition off my tape diagram into fourths, and then I need to shade in one of them. So that's 1 fourth. And I knew that because my denominator was 4, so I needed 4 pieces, and my numerator was 1, so I shaded in 1. Now I need to do 3/5. So now again, I'm trying to do the best I can to partition that into 5 equal pieces. Why 5? My denominator is 5. Remember, the denominator tells us how many pieces we need, and the numerator tells me how many to shade in, and in this case, I need 3. So I do 1, 2, 3. And again, it's really clear to see that 3/5 is greater than 1 fourth. Okay, so now let's do the other thing that I had listed, which was get common denominators. So I want to get common denominators for these. The rule, remember, is that I multiply the fraction by the other fraction's denominator. So if I'm going to take 1 fourth and I'm going to multiply it times that 5. And when I'm working with 3/5, I'm going to multiply it times 4. So let's go ahead and do that. Uh-oh, I don't remember which one of these is my narrow one. Not that one. Okay, so let's take 1 fourth, and let's decompose that so we can get a common denominator. So I'm going to take 1 fourth, and I'm going to multiply it. What am I going to multiply it by? The other fraction's denominator, which is 5. And whatever I do on the bottom, I have to do on the top. 1 times 5 is 5. 4 times 5 is 20. Now let's do the same thing with 3/5. So for 3/5, now I'm going to take 3/5 and I'm going to multiply it by the other fraction's denominator, which is 4. 3 times 4 is 12, 5 times 4 is 20. And so now I can just take a look. What do I have going on here? Well, I can see that now I do have common denominators. My denominators are 20 because I decomposed both of these into 20ths. So remember, these are equivalent, these are equivalent. So now I can just, since my denominators are the same, I can go ahead and just compare my numerators. And I can see that 5/4 is a lot less than 5/20 is a lot less than 12/20, which means that this one's smaller and this one's larger. I like to circle the larger one. So then when I write it, I want to use the original equations. So I'm going to say 1/4 is less than 3/5. Okay, so there we have it. 3 different ways to compare the fractions when our denominators are different and when our numerators are different. Okay, I want to do a couple more problems for you really quickly, just so that I know you have a good solid review. Where did I just took all my paper out from under there. Here we go. Okay, so grab some more paper for us. And I have about 4 problems I'm going to do, but the first 2 are going to be so quick. So quick. So let me just grab my markers again. Okay, so the first one is, let's compare 2/7 and 2/4. So for this one, again, the first thing I want to do is see, do I have common numerators or common denominators? Are they the same? And sure enough, in this case, I have 2 and 2 in my numerator. And remember, when our numerators are the same, we can just look at our denominator to see which pieces are bigger and which pieces are smaller. In this case, 4 means that I have much bigger pieces because 4 is smaller than 7. My pieces are going to be bigger. I'm cutting up into fewer pieces. If you had an apple, you cut it into 4 pieces, those pieces would be a lot bigger than if you cut your apple into 7 pieces. So remember, when the denominator, the number in the denominator is smaller, the pieces are bigger. So since I have 2 of each of these pieces, I want the bigger pieces, right? And so I can go ahead and write that 2/4 is greater than 2/7, or 2/7 is less than 2/4. Okay, so that was quick. Let's take a look at another one. Let me just slide this up a little bit. Let's do 3/6 and compare it with 5/6. All right, so for this one, my denominators are the same. And when your denominators are the same, you can just look to see who has more pieces, who has a bigger numerator. Because this is telling you that all my pieces are the same size. They're all going to be 6. So who has more of them? Here, 5/6 is definitely going to be more because there's 5 pieces. Here, there's only 3 pieces. What size are they? They're 6. All right, so let's take a look at another problem. Let's do 2/4 and let's compare it to 3/5. So again, one option is I can put both of those on a number line. And I'm going to do such a quick jot right now. Oh, this looks really familiar before we did 1/4. So we have 0, we have 1, we have a half. So 2/4, 2 is actually half of 4. So I know that that's going to go right here. I'm going to have 2/4 right here. It's equal to 1/2. What about 3/5? Well, we just did that. We know 3/5 is between 1/2 and 1, closer to the 1/2. But we just proved it. 2/4 is less than 3/5. Okay, one more, I think. Oh wait, I want to show you another way. I'm so sorry about that. I just had to jog my memory for a second. So we did this in this way. We could have drawn a tape diagram for it, just like we did before. But let me do one more of these where we get common denominators. So I could take 2/4 and I can decompose it by multiplying it times the other fraction's denominator. So I'm going to take this fraction and multiply it times the other fraction's denominator, which is 5. And whatever you do on the top, you have to do on the bottom. 2 times 5 is 10. 4 times 5 is 20. Now we have to do the same thing with 3/5. So we have 3/5, and we have to decompose it so that we can, compare it to the other fraction. And how do we decompose 3/5? By multiplying it by the other fraction's denominator, which is 4. And then I get 12/20. Well, now I have common denominators. I have 10/20 and 12/20. They both have 20ths. So what I can do is I can just look at my numerator, right? And here I have fewer pieces, here I have more pieces. So 12/20 wins. So I could rewrite them, or we have it right here. We know that this one's bigger, which means this one's bigger, which is exactly what we already wrote. Okay, so now that we've done that, I want to just point one more thing out at the bottom of the paper. So it said, if you compare fractions greater than 1, turn them into mixed numbers to compare them. So for example, 17/5 is equal to 3 2/5. So let's do one of these. Let's compare, and you know what, I feel like I want to make sure that I have enough room to do this. So let's compare 10 halves. Oh, no, that's not what I wanted. Sorry. Boom. Let's compare 10 thirds and 7 halves. So if I'm comparing 10 thirds and 7 halves, my denominators are different, my numerators are different, so what am I going to do? Well, let's first of all take a look at these and realize that those are fractions greater than 1. And whenever you have fractions greater than 1, the absolute first thing that you have to do is you have to turn them into mixed numbers. So here we go. So for this one, what I'm going to remember is that 1 is equal to 3 thirds. And this is kind of not a great one. Let's use this one. So 1 is equal to 3 thirds. So what I want to do is I want to pull out groups of 3 thirds out of this. So I'm going to put 3 thirds here, and that's equal to 1. 3 thirds here, so that's 6. 3 thirds here, that's 9. So if I'm up to 9, if I did another 3 thirds, I would go up to 12 thirds. That's too much, I only have 10 thirds. So I'm going to put that last one right here. So I had 3 thirds, 6 thirds, 9 thirds, 10 thirds. Now, I want to turn this into mixed numbers, so I have to take each of these and realize that 3 thirds is 1, 3 thirds is 1, 3 thirds is 1, and a third. So we have 3 and a third. Okay, so now let's decompose this one. So let me grab a different color for us to decompose that one. I think blue will be okay. So, in this case, what I know is that 1 is equal to 2 halves, or 2 seconds. That would make up one whole. So I want to pull 2 seconds out of this. So I pulled out 1. So I had 7, now I have 5. I pull out another one. Now I have 4 out here, right? So I had 7, I have 2, 4, 6, and now I need just one more to make 7. So now we have 2, 4, 6, 7. All right. So now this is equal to 3 and a half. So what you are hopefully noticing is that our whole numbers are the same. When they're the same, we can kind of hold them on the side and just work with the fractions. So here we have a third and there we have a half. My numerators are the same, so I can look at the denominators and see which one's bigger and which one's smaller. This is going to be more pieces, so the pieces are smaller. This is fewer pieces, so the pieces are larger. So that means that 3 1/3 is less than 3 1/2. All right, so that is a review of comparing fractions. I want to just really quickly show you what you're going to do. I am pushing out this review to everyone that I showed you before, comparing fractions review. So that will be waiting for you in our Google Classroom. And then I am pushing out, this is just 10 really quick problems. Remember, a whole bunch of them are going to have common numerators or common denominators. They're going to be super, super duper easy. Like you can do these two in probably about 10 seconds flat for both of them put together. So we're going to work through this. It's 2 pages. It's only 10 questions. It just looks much larger. And then you are going to have the opportunity, if you want, to do a quiz review. And it'll just give you an idea of where you're at. So I'm not going to go through all this, but just know that there's a quiz review that I'm pushing out to you, and I would like it done by Friday. All right. So thank you, everyone. It was so nice to be here in our Google Classroom with you, and I hope to see you tomorrow bright and early. All right, have a great night.